Right now, a machine built by human hands in the 1970s is drifting blindly through a darkness so absolute that our sun is merely another fading star. It is billions of miles from Earth, running on borrowed time and facing a slow, silent death with zero chance of rescue. But here is the paradox. When its heart finally stops beating, its journey is just beginning. Welcome to Astro Trivia. Today we are tracking Voyager 2, where this immortal ghost ship is heading and why it will never ever stop. To understand where Voyager 2 is going, you have to understand the sheer astronomical luck that got it there. Launched on August 20th, 1977, from the salty coasts of Cape Canaveral, Florida, this probe actually left Earth 16 days before its famous twin, Voyager 1. But NASA intentionally placed Voyager 2 on a slower, sweeping trajectory. Why? Because the brilliant engineers at the Jet Propulsion Laboratory realized they were sitting on the edge of a cosmic lottery ticket. A rare planetary alignment was happening, one that only occurs once every 176 years. Jupiter, Saturn, Uranus, and Neptune were perfectly positioned in a sweeping arc across the outer solar system. This meant that if NASA timed the flight path with absolute mathematical perfection, the spacecraft could use the gravity of one planet to slingshot itself toward the next. It is the orbital equivalent of grabbing the bumper of a passing semi-truck to launch yourself forward on a skateboard. You gain massive speed without burning a single drop of your own precious rocket fuel. And the physics worked flawlessly. In the summer of 1979, Voyager 2 screamed past Jupiter, capturing mind-bending images of the Great Red Spot, a raging anticyclone large enough to swallow the Earth whole. But the real shock came from Jupiter's moon, Io, where the probe confirmed active, violently erupting volcanoes on a frozen rock that scientists assumed was geologically dead. By August 1981, the probe was riding its gravitational high-speed rail to Saturn. It peeled back the mystery of those iconic rings, revealing not smooth, solid bands, but thousands of intricately braided ringlets, herded by the gravity of tiny shepherd moons. But Voyager 2 wasn't done. Unlike its twin, which angled upward and out of the planetary plane after its Saturn flyby, Voyager 2 kept surfing the alignment. In January 1986, it achieved the impossible, becoming the first and still the only human-made object to visit Uranus. It found a bizarre world knocked entirely on its side, rolling through the dark like a barrel, dragging a skewed off-center magnetic field. Finally, in August 1989, it grazed the cloud tops of Neptune. Skimming just 3,000 miles above the methane ice, it recorded supersonic winds whipping at over 1,200 miles per hour and discovered cryogenic geysers spewing nitrogen on the frozen moon Triton. In just 12 years, Voyager 2 had rewritten every textbook on planetary science. But after Neptune, there were no more planets to surf. The grand tour was over. The long, relentless, dark exile out into the void had begun. Right now, Voyager 2 is hurtling away from the sun at roughly 34,000 miles per hour. It has no engine thrust left, riding purely on the ghosts of momentum. So what is keeping its electronic brain awake out there in the freezing deep? The answer lies in three small, incredibly resilient devices known as radioisotope thermoelectric generators, or RTGs. These robust generators are the only reason this mission has survived for over 4 decades. They're not traditional engines, they're atomic batteries powered by the radioactive decay of a highly volatile isotope called plutonium-238. When Voyager 2 launched back in the disco era, these generators produced about 470 watts of electrical power. To put that in perspective for you, That is slightly less power than what your kitchen microwave uses to heat up a cup of coffee. Yet, remarkably, that meager output was enough to run 10 sophisticated scientific instruments, a suite of survival heaters, onboard computers, and the critical radio transmitter, sending all that priceless data back home. But here's the grim, inescapable reality of nuclear physics. Plutonium-238 has a half-life of nearly 88 years. That means as the radioactive material naturally degrades, the spacecraft's power supply drops by roughly 4 watts every single year. 4 watts might not sound like much of a loss to us down here on Earth, but when your survival depends on a finite trickle of electricity, losing 4 watts is devastating. It is the agonizing difference between keeping an electronic eye open to study the cosmos and shutting it off forever to save the core. For decades, the mission engineers at NASA's Jet Propulsion Laboratory have been playing a high-stakes game of cosmic triage. To buy the spacecraft more time, they've been forced to make heartbreaking decisions. One by one, they have systematically killed off the probe's capabilities. Cameras were powered down, spectrometers were shut off, even the vital heaters that keep the fragile wiring from freezing and snapping in the deep cold have been turned down or disabled. They are bleeding the ship's functions dry just to keep its heart beating. But the math is unforgiving. Sometime in the 2030s, the decaying plutonium will cross a fatal threshold. The power output will drop below the absolute minimum voltage required to operate that 22-watt radio transmitter. And when that exact moment arrives, the engineers will have no choice left. Voyager 2 will transmit its very last whisper of telemetry, and then it will slip into permanent, irreversible silence. In November of 2018, Voyager 2 shattered a boundary most people do not even realize exists. It crossed the Heliopause. Now, what exactly is that invisible threshold? Our sun constantly blows out a supersonic stream of charged particles known as the solar wind. This wind inflates a massive protective magnetic bubble called the heliosphere, which essentially shields our planets from the harsh realities of the broader galaxy. The heliopause is the exact turbulent point where that solar wind finally loses its strength and can no longer push back against the immense pressure of the interstellar medium. By crossing this definitive line, Voyager 2 officially became only the second human-made object in history to pierce the veil and enter the vast space between the stars, following its twin probe, which crossed back in 2012. But here is where the mainstream media often gets it completely wrong, and it is a crucial scientific distinction you need to know. Entering interstellar space does absolutely not mean that Voyager 2 has left the solar system, not even close. It has merely stepped out of the sun's protective front yard and into a chaotic, unshielded neighborhood. Out here, the environment changes drastically. The particles slamming into the spacecraft are no longer coming from our friendly sun. Instead, the aging probe is being relentlessly bombarded by galactic cosmic rays, high-energy atoms blasted out by ancient, violently exploded supernovae from the deepest corners of the Milky Way galaxy. This environment is fundamentally hostile to those degrading 1970s electronics. Yet, against all odds and basic logic, Voyager 2 is still talking to us. The way it communicates is nothing short of an engineering miracle. The spacecraft transmits its data using a radio signal operating on roughly 22 watts of power. That is essentially the equivalent of the tiny dim light bulb sitting inside your refrigerator. That fragile signal has to travel billions of miles across the freezing void, taking more than 19 grueling hours just to bridge the gap to Earth. By the time those weary radio waves wash over the massive 70-meter listening dishes of NASA's Deep Space Network, the signal is incomprehensibly faint. To put it in perspective, the energy carrying that vital data back to our screens is mathematically weaker than the kinetic impact of a single falling snowflake hitting the ground. It is a microscopic whisper in a screaming cosmic hurricane. And yet, we are still catching that snowflake, deciphering its structure, and learning what the dark universe truly looks like outside our little solar bubble. If Voyager 2 has not left the solar system yet, what exactly lies ahead? Out there, surrounding our entire planetary neighborhood, like a vast spherical shell, is the Oort Cloud. This is a theoretical freezing reservoir made up of trillions of icy objects left over from the formation of our solar system. It is unimaginably massive. The inner edge is thought to begin at around 1,000 astronomical units from the Sun. The outer edge pushes out to a staggering 100,000 astronomical units, stretching nearly 2 entire light years into the black. Voyager 2 is traveling at breathtaking speeds, yet space is so incomprehensibly large that it will still take the probe roughly 300 years just to reach the absolute inner edge of this cloud. Once it enters that frozen shell, it could take another 30,000 years to pass through it entirely. Let us put that immense stretch of deep time into perspective. 30,000 years ago, humans had not even invented agriculture yet. We were living in caves, painting pictures of animals on stone walls. The absolute entirety of recorded human civilization fits comfortably inside the time it will take this one piece of metal to cross a single lonely region of our own solar system. And for all of those 30 millennia, Voyager 2 will be completely dead. It will just be a silent hunk of metal tumbling blindly through a dark cloud of primordial debris that no human eye has ever witnessed. If it survives the Oort Cloud, Voyager 2 will eventually become a true interstellar wanderer, drifting toward other stars. In roughly 42,000 years, it will pass within 1.7 light years of a small red dwarf star known as Ross 248. But do not let the word pass fool you. 1.7 light years is not a close encounter. The star's gravity will not capture it. The probe will simply drift past unnoticed, an invisible speck in an ocean of nothingness. And if it remains undisturbed for another 296,000 years, it is projected to glide within 4.3 light years of Sirius, the brightest star in our night sky. It will never stop. It will simply continue on a permanent, endless orbit around the center of the Milky Way galaxy. But here is what makes the story of Voyager 2 so much more than just a cold physics problem. Bolted securely to the side of the spacecraft is something profoundly human. A 12-inch, gold-plated copper disc designed specifically to survive and be playable for up to 1 billion years. This is the golden record. It was the brainchild of astronomer Carl Sagan, who deeply understood that exploring the cosmos is not just about crunching raw data, it is about meaning. Sagan and his team encoded this disk with a snapshot of who we are. They etched 116 analog images of Earth onto it, pictures of mountains, oceans, cities, and a mother nursing a child. They packed it with the booming sounds of thunder, the calls of whales, and human laughter. It features greetings spoken in 55 different languages. It holds 90 minutes of humanity's greatest music, from Beethoven to Chuck Berry. But perhaps the most poetic inclusion belongs to Anne Druyan, the project's creative director. During the intense process of creating this record, she and Sagan fell deeply in love. Druyan had her brainwaves and her heartbeat recorded, compressing the raw biometric data of a woman newly in love straight onto the disk. Right now, her heartbeat is flying through the freezing void, billions of miles away from where it was first felt. Voyager 2's electronics will inevitably die in the 2030s. Its metal chassis will be slowly eroded by cosmic dust over millions of years. But that golden record is projected to remain intact for an astonishing 1 billion years. Long after our current civilization has crumbled into dust, long after the Earth's continents have shifted beyond all recognition, that disk will still be out there. It was never designed for immortality. It was just designed to take some quick pictures of Jupiter and Saturn. Everything after that has been an extraordinary gift. The void will not mourn its passing, but we built it, and we aimed it at the very edge of everything we knew. Thank you so much for joining us on this journey here at Astro Trivia. If this deep dive sparked your curiosity, please hit that like button, share this video, and subscribe to Astro Trivia for more mind-bending stories. Keep looking up, and we will see you next time.